Hello everyone, and today is the 14th of December, and we are ready to go with the task. So let's see. There's some map again, some positions and velocities. Some robots will be moving. Yeah. Let's see what's the description is about.
One of the historians needs to use the bathroom. Fortunately, there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, EBHQ seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. To get the historians safely to the bathroom, you'll need a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines.
Okay, so the robots are moving on the tile floor.
You make a list, your puzzle input, of all of the robot's current positions, P, and velocities, V, one robot per line.
Okay.
For example,
so here we got different robots. They have initial starting positions and velocities. Assumingly, it's n in the x and y axis, and the same for velocities.
Each robot's position is given as p equals y, where x represents the number of tiles the robot is from the left wall, and y represents the number of tiles from the top wall when viewed from above. So a position of p0 thou means the robot is all the way in the top left corner.
Top left corner, okay.
Each robot's velocity is given as vxy, where x and y are given in tiles per second. Positive x means the robot is moving to the right, and positive y means the robot is moving down. So a velocity of ve12 means that each second the robot moves one tile to the right and two tiles up. The robots outside the actual bathroom are in a space which is 101 tiles wide and 103 tiles tall when viewed from above. However, in this example, the robots are in a space which is only 11 tiles wide and 7 tiles tall.
So yeah, we start from the initial position, which is a top left corner. It could be different from your perspective. From my perspective, this is top left corner. And when we go down, it's increasing. Y increases and X increases when we go right. That's why when we go the other direction, so to go up, we should decrease the Y. When we want to go left, we should decrease the X axis. So we have in our puzzle input, supposedly we have 101 tiles wide and 103 tall. For this example, we have how many tiles? 11 wide and 7 tall. Okay, the robots.
The robots are good at navigating over under each other due to a combination of springs, extendable legs, and quadcopters, so they can share the same tile and don't interact with each other. Visually, the number of robots on each tile in this example looks like this.
Okay, so they can share the same tile and don't interact with each other. Okay, so if the robots at one point in time they will come into one tile, they can do that. They will not bump into each other. Okay.
These robots have a unique feature for maximum bathroom security. They can teleport. When a robot would run into an edge of the space they're in, they instead teleport to the other side, effectively wrapping around the edges. Here is what robot P24V23 does for the first few seconds.
So this is basically what we have in Snake game, where you go as a snake. When you control the snake, if the snake just goes to the corner, to the edge, it will appear on the other side. So that's how they say teleporting these robots. I won't read all of this. Okay, let's go.
The historian can't wait much longer, so you don't have to simulate the robots for very long. Where will the robots be after 100 seconds? In the above example, the number of robots on each tile after 100 seconds has elapsed looks like this.
So this is so far this is a pretty simple task. You just simulate the robot movements by their constant velocity and by those rules that they teleport to the other side and that they cannot interact with each other. So this is no limitation from there. What else?
To determine the safest area, count the number of robots in each quadrant after 100 seconds. Robots that are exactly in the middle, horizontally or vertically, don't count as being in any quadrant, so the only relevant robots are
Exactly in the middle. Don't count as being in any quadrant. So we should divide the whole space into 4 sides, 4 parts, equally. So half vertically, half horizontally, and we need to count number of robots in each quadrant. Then we skip all the robots that are in the middle. And what's next?
In this example, the quadrants contain 1, 3, 4, and 1 robot. Multiplying these together gives a total safety factor of 12. Predict the motion of the robots in your list within a space which is 101 tiles wide and 103 tiles tall. What will the safety factor be after exactly 100 seconds have elapsed?
Okay, so after we've divided our space into four parts, the quadrants, we count number in each quadrant, number of robots, and then we multiply those 4 numbers, and we get our safety factor. Yeah, and we skip the middle ones. So no problem there. I'm pretty sure that small models will be able to solve this task, this part. So let's proceed to the day 14. We'll insert our input. We have 500 lines. Yeah, and sorry, I need to increase the window size and the font. Now let's copy that. And let's actually use again one mini. Let's paste the description. It already has the code it has to insert into. So solve this task, part 1 only. Unsupported model. Okay, so agent is not supported for O1 mini. Yeah, let's wait until it generates some code, and let's see if this would be correct. Probably yes. And then, as always, as not always, as last days, I will submit to all other models both parts of the task, and we'll see how each of them will do that. Okay, not so much code. We can see that even here. So it's firstly parsing position and velocities. We have a list of robots with positions and velocities. Then simulate 100 seconds. So yeah, all right. So what do we have here? Width and height. So we go for iteration in range 100. We go for our robots for their positions and velocities. Then we do x plus vx. So this means it will be the new x position when you multiply there. What do you have here? X is a coordinate. Is it correct though? So the percentage width will do the cycling thing. So whenever we get to the point which is higher than the width, it will return back. So the remainder position will be placed. So if we have width of 10, for example, and our new x is 15, the remainder will be 5. Therefore, we go full 10 points, and then it goes back, and then full and then 5 points, like 5 tiles again through the x-axis. So this will do this cycling thing with the percentage sign. But I'm actually not sure if that one is correct. So because we have because we have the velocity in tiles, like tiles per second or tiles per iteration, it's the same thing, 1 second, 1 iteration. So we probably shouldn't multiply v by x. I'd say just x plus v multiplied by 1. But yeah, I may be wrong. Could be wrong. Count number robots in each quadrant. Then we divide it width in 2, height in 2. We have our quadrants, which are that's not quadrants, but robots in quadrants. Then we go for x and y and velocities in robots. If x and y or y in the middle, then we skip the robot. If it's less than middle, so we basically those are the quadrants definitions. Before middle x, before middle y, and more than after middle x, but before middle y, and the other way around. Then we have safety factor, which is 1 by default for some reason. And then we count the robots in quadrants, and we add that to the safety factor. Okay, so because we need to multiply them, we initialize it with 1, not 0, because anything that we are going to multiply by 0 will come 0. Okay, so apart from this part, I'm sure it's fine, but let's see how it goes. So cd day 14 and Python. Let's go to the solutions. Python 01 mini. Let's see. No. Python 01 mini. Okay. Yeah. Another parsing issue. What could it be? So it definitely should be correct. There's no. Why do you do that? How do you parse it? Split lines, line split. We have parts 1 and 2. Then we have positions, parts, first part, then 2, what? From 2. Okay, so we skip 2 symbols. We get this number here, and then until -1, so probably. Yeah, I'm not sure why it's the what's wrong with that. Let's see. So x and y. Print position. Print. Yeah, just position. Yeah, and v velocity. Let's see. So okay, 70 and nothing. 75 and -3. 70. Nothing for some reason. Okay, so it just failed to parse. So these are positions 77, 75, -3, -38. Okay, bad day for O1 Mini, but I'll give it a hint anyway. Make so the positions, and I'll just do it another way. The use regex to parse correctly, and I'll use the same prompt for other models as well, because we have seen not once that even GPT-4 was failing to parse input data and not even going through the solution. So yeah, let's see. We have a pattern. Okay, now it's mostly correct, probably. Quadrants. All right. The code is nicer this time. So, split lines, match pattern, parse our positions and velocities, calculate new position with wrapping. Okay. All right. So now, can you see that? This is a different approach. Previously, it was simulating. So it was going through the 100 iterations, and it actually tried to simulate the position changes in the position, but now it's calculating them instead, and this is the correct approach, because you have displacement by x coordinate, which is initial position, initial x position. Then we have vx, which is a velocity, and I was wrong that time, because there was no multiplication. Vx is a name of a variable, not a multiplication of velocity and x. So yeah, well, that's probably was my bad. But yeah, in any case, we have time lapsed, which we want to calculate, which is a 100 seconds. So we multiply velocity by time, and we get our new coordinate. We add it to the initial coordinate, and then we cycle them if the number is bigger. So we can just get the remainder of this x position. The same goes for the y. Then we divide the quadrants and count and calculate the scale factor. So currently should be correct one. Okay, we have our number. Hopefully it's correct. And let's see. Yeah, 1 gold star, perfect. Good. Well, let's read part 2.
During the bathroom break, someone notices that these robots seem awfully similar to ones built and used at the North Pole. If they're the same type of robots, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. What is the fewest number of seconds that must elapse for the robots to display the Easter egg?
How do you even do that? Apart from visualizing this, all right. I have no idea how AI could how would I approach this, apart from visualizing and then looking through the iterations and trying to figure out what's the Christmas tree shape should be. How would AI approach this? I have no idea. So let's see. Let's test on 1 mini again. Hey, hello. Okay, let's remove our puzzle input and statement that it was completed. Okay, yeah, day 14, blah 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 blah. Okay, part 2. Okay, solve the task. Both parts. Use regex to parse correctly. What else should we be creative? I don't know. With the second part. Okay. And yeah, we should do what we should do now. I'll copy that to O1. Okay, OpenAI O1. Our template, our task description, our prompt. What's that? Okay. Now, solve the task. Both parts. Use regex. Be creative with the second part. What else? Yeah. All right. So, and I forgot to copy that again. And so, okay. Here we go with the O1. Oh, it's ready. Okay. We have solution from O1 mini. Let's go into Claude as well and ask for Claude 3.5 HiQ firstly. Prompt it. Okay, it started writing some code. Then we should we do what? Okay, I'll open up a DeepSeek and Gemini as well. DeepSeek chat. So firstly, let's go to Gemini. We have Gemini Experimental 1206, which is quite smart. Okay, let's run. And let's also go with DeepSeek with enabled DeepThink. Yeah, and let's see what we get from all our models. Okay, tree pattern. Check this. This can be enhanced. So yeah, this doesn't remind me of Christmas tree at all. Could be that it will just won't solve it. Okay, O1 mini try. Yeah. We'll take take it to run for some time. Let's go through the O1 and okay, part 1. What's happening? Okay, position simulate VX by seconds. Okay, this is almost the same thing or just the same from O1 mini what we get. We suspect that some second the robots form a special Easter egg pattern, example Christmas tree. Without actual target pattern, we need strategy. We'll guess that the puzzle, as hinted, is related to observing a recognizable pattern at some time. Typically, such puzzles might require checking consecutive time steps until the arrangement spells out something visual recognizable. We simulate until a certain stable pattern emerges, or until a small bounding box of points forms. Heuristic approach, simulate robots over time. For each second, compute the bounding box of all robots' positions. Alright. This is a smart move. The moment the bounding box is minimal or below a certain area threshold, return the time. So if we have robots moving like abstractly and not abstractly, chaotically through all the area, but at one point they should clump all together at some area which is smaller than the whole. That's how we determine if they formed some pattern, not pattern, but some image. That's why it's saying bounding box. So they will be all in some area. There will be no robots outside. But that's only if all the robots will be forming this Christmas tree, and we might not know if other robots will be flying around that Christmas tree. So this is a common approach for similar puzzles like Advent of Code 2018 Day 10. Alright, we'll implement that heuristic, keep simulating until bounding box starts growing again, then minimal area configuration is the Easter egg. No, the puzzle states very rarely range themselves into the picture, and we'll assume a minimal bounding box method. We'll brute force from T1, T0 upwards until we see that bounding box. Alright. Let's see what... Yeah, we have some number from O1 Mini. Interestingly, that it has found something, at least something. But yeah, we have our O1 model, and we have a solution from it. Let's firstly go and try that number for our solution. Whoa! I haven't expected that. Alright, so just to make sure, yeah, it's O1 Mini. O1 Mini did that. Okay. And how long did it take to? I don't see it. So we run it inside the composer, and that's why we can't see the time elapsed. But all right. Did you really try to check for this pattern? And we'll probably need to visualize that and see what pattern emerged. All right. Let's see what will O1 take us to get us. So O1 did incorrectly. This is we won't have two different answers. Yeah, I mean correct answers. So okay. So O1, as I thought, was getting a correct approach, but O1 Mini did it correctly. By checking this just simple pattern, free pattern. Did it actually use it? I wonder. Just wait a bit. What was the solution from O1 Mini? So tree pattern. Okay, pattern height or pattern width. For okay, yeah. If tree pattern is this hash sign and grid is not match false, break if not match. It seems like it's just checking this pattern. Is this correct pattern? Okay. What did O1 did us? So bounding box area positions. For x and y, we get all the x's, all the y's. Then we calculate maximum x's x position, and then minimum minus minimum plus 1 multiplied. So how we get the area. We want to calculate the area, so we get the difference between x and x, then y and y. So we get distance between those points and multiply and we get area. So it's like we get the smallest area possible, and this happens in only 23 seconds. And yeah, it's the wrong answer. All right. I won't be spending another request with O1 because there are only 50 for the week. We have some answer from DeepSeek. Let's try it out. DeepSeek, and let's run DeepSeek. No input, no problem, because it's in the other directory. Okay, so we have a correct answer. So yeah, the first problem is too easy. Yeah, let's write down our results. So O1 did get us success for the first one, but failed for the second. Now we get our O-mini, which did get us both successes. Yeah, success and success again from only one attempt. And then we tried, it's not even here, DeepSeek. Yeah, success and failed. No, please, failed. Now we can just try Gemini, which is over there. We'll go see whether it's code correct. Yeah, again, input. Let's see with Python Gemini. The first one is correct. Okay. The second one is correct as well. Okay, 1 point for Gemini. Let's write it down for Gemini. Yep, success. Okay. And now Gemini, let's see how it solved that. The second part is Christmas tree. So it checks if the robot configuration vaguely resembles a Christmas tree. This is a very loose approximation based on the idea of central trunk and the branches spreading out with more robots towards the center of the bottom. Oh wow. Total robots less than 10, then false. Middle X, middle Y, trunk count, branch count, bottom count. For X and Y count grid items. If absolute, X minus middle X less than or equal to 1, then Y is bigger. We add it to the trunk. Okay, so we go through the grid, and if we see that the X is not changing and X and middle X, okay, so we it should be positioned exactly in the middle of the grid. That's why we get the middle X, and there should be a trunk, and therefore if we go towards the bottom, probably we add them to the trunk count, then we somehow calculate the branches. Not sure about the logic here. So if Y is more than middle, Y bottom count. Trunk count, total robots 0.1. Branch count, total robots, more than total robots, 20%, and bottom count, more than total robots, like 40% of the robots in the bottom. Okay, how does it do the Christmas tree grid? Grid is simulate robots. Okay, so it's just doing with all the grid. Wow, nice approach. Okay, good for you, Gemini. Let's close it. Let's close DeepSeek O1, and yeah, let's try now with not O1 but with GPT-4o. And then let's see what Claude 3.5 Haiku got us. Copy contents, Claude Haiku, Haiku. Okay, yeah, there's something now. Something is here. Part 2. How did it solve it? Find time when robots form a Christmas tree pattern. Is Christmas tree. Look for a tree-like pattern. Creative interpretation of a tree formation. Trunk bottom, trunk middle, trunk top. I'm not sure. I'm really not sure. Claude 3.5 Haiku. Bull is not iterable. I'm just wondering whether the approach is correct. So it's definitely a fail. For the second part. For the first part, it's correct. So, all, return all. Christmas tree. So if Christmas tree return seconds, where do we get this? Bool is not iterable. So yeah, it seems like we need to have a list of this whole thing. X and Y in normalized or sum for okay, yeah, it's the same thing. List bool is not iterable. Okay, it's in normalized. So normalized is bool, is boolean. Normalized Y. So bool is not iterable, or probably tree shape. Tree shape is boolean. Which one is boolean? Or sum. Normalized. What's arguments of the bool cannot assign to parameter iterable of iterable objects in function O. O is incompatible. X and Y in normalized. Where did you get bool? Okay, anyway, yeah, I could just try to fix this problem here. Oh yeah, I've pasted the incorrect error, but hopefully it should find out. Yeah, please. Why did it take so long? Go. Proceed. Okay. If any, return any in normalized. Why did it now? Same. Keep the conditions. For X and Y in tree shape. Haven't been missing. You know, it's a correct one. Okay, let's see what's the answer. It's calculating. Gemini did get us like straight away. Okay, while it's thinking, while we're waiting, let's go with the sonnet. Hey, see, why haven't you copied this one? Okay, never mind. Let's go, start with Sonnet. Still no answer. We have something though from the GPT-4o. Yeah, we have something. Okay, can we copy the code? Is this? No. Okay. So this was GPT-4o. Yeah, seems like it's correct. Okay, seconds for tree formation is -1, so no points for Haikyuu. Let's go and success and failed. Why did you fill up the other ones? Okay, so we have left for GPT-4o and Claude 3.5 Sonnet and also GPT-4o Mini. Let's go. We can close Gemini. Where's that? Again. Copy GPT-4o. Oh yeah, I've already did that. GPT-4o. Again, the correct answer for the first one. Pretty simple. Success and yeah. Success. Why do you want to write down all the success and then please stop? It's still answering. Okay, so this is the answer from Claude Sonnet. And let's go to the file Claude 3.5 Sonnet. Insert the code. Okay, now we get something like robot data class with points with a method to move. I like this approach. When I wrote my solutions for Advent of Code myself, I always try to use this like classes, data class of robots, and just make the code cleaner and more readable. Like you can even create a visualization or a game from that afterwards. So we have a check Christmas tree. Define a simple Christmas tree pattern. This is a basic example. You might want to adjust based on the actual pattern. No, you actually had to do that, not me. So we have some width, some height, some coordinates probably. Yeah, we need to check that. Orbit positions. So we need to, and it checks if all the positions are in this pattern, which is probably not the correct solution. Yeah, we'll wait until GPT-4o finishes, but now let's see Python, which is Claude 3.5 Sonnet. Again, the correct answer for the first part and incorrect for the second part. Okay, so Claude didn't manage to success, failed. And probably this one will fail as well. We have left only GPT-4o Mini. Yeah, I'm pretty sure GPT-4o Mini will solve the first one as well. And I'm 100% sure that it won't solve the second one. Okay, parse input. Okay. Function to simulate robot movements. Okay. It doesn't multiply. Okay, we don't need to multiply that there. Okay, calculate safety for 100 seconds. Find the earliest time when the robots interact. Brute force approach. Minimum robots recognizable shape. Check Christmas tree shape. You can adapt. Okay, grid. For robots and robots. Position is Christmas tree. Here implement more sophisticated method to detect Yeah, that's what just happens with GPT-4o Mini. It just says, solve it yourself. Let's see if at least the first one is correct. No. Why? Even the first one it failed to get correctly. Is there some errors recognizable? So robots, simulate robots, grid, create a grid to store robot counts in each position. What? Count robots in each position? No. It'll probably, yeah, that should be an issue. So it counts the robots in each position while, no, it could be correct. Count the robots in quadrants and hard coded 51 for range in 51. Yeah, just failure for both of the tasks. GPT-4o Mini who wrote down the success. Failed. Both failed. Okay, let's see. O1 success fail. O1 Mini success fail. Gemini success. And GPT-4o Mini fail. HiQ success fail. GPT-4o still counting. Probably is incorrect. And Cloud Sonnet success fail. Okay. So we get our results. I'll probably stop that. It's just we'll never stop. Okay, so we'll write down failed. Okay, here are the results, and let's firstly submit it and add day 14 solutions. Okay, and yeah, that's it. Let's close this down. Let's see what we have in our advent calendar. Wow. I wonder what that symbol is. Oh, just... Can you see that? Yeah. How did they do that? It's like a comment. Okay. So, yeah, this is probably a number 10 and with some Christmas patterns inside. Let's visualize. I really wanted to visualize this solution, or not the solution, but the pattern, to see the pattern, what we got. Okay, let's ask our agent, which will be running on Claude 3.5 Sonnet, and I'll ask it to please visualize the grid. Nicely with colors and some Christmas theme with matplotlib on the when it has can we generate a movie, like a moving pattern? Visualize grid nicely, great animation with robots moving with matplotlib until the Christmas tree appears, and then stop and wait until Like just stop and then stop. Can we do that? Okay, we have a animation visualization. Let's accept this and let's run. Okay, no module named O1 mini. Okay, yeah, that's because, yeah. O1 mini. What do you fix? It won't fix anything. No such day on directory. Yeah, because we are already inside. Oh, okay. It will move the O1 mini file to the another file name, so it renames it. Okay, it's generating, but nothing comes out. Yeah. Okay, I can do this myself. Okay, I see the issue. No, do not do that. Okay, so Python visualize and no module named O1 mini because it hasn't moved it. Why do you do that? Okay, anyway, O1 mini to O1 mini y, and let's do that. Okay, visualize. I don't see any movements. Okay. I don't see any movements, by the way, and no robots, by the way. Make the time, like, if we have let it be like 60 FPS and 1 frame is no, not 1 frame, and 1 second should be like 1000 iterations second in the robot's time. Should be 1000 iterations. Okay, speed up the animation to 60 FPS. Make each frame multiple robot movements. Yeah, alright. Accept. Let's run it again. I don't see anything. Why? For some reason, there are no robots there. Only blue screen.
Attention, the air alert is over. Force be with
Okay, we have something. Let's see. Again, I don't see anything. Double check once again. No robots on the blue screen. What can be incorrect? It's thinking. Let's try to figure out it ourselves. Okay, it tried to read the input. What was the issue? Let's make sure the plot limits are correct. Let's add grid lines temporarily to help debug. Modified version. The sample data. Tries to visualize the sample data. Okay, see at least something. Yeah. Nothing again. Nothing again. Oh, it's not that. Visualize, okay. Alright. You have something else. Let's run it again. And yeah, nothing again. What's wrong with that? Is Christmas tree. How did it? Okay, accept. Draw color positions, X coordinate, alpha, more opaque, marker, edge colors, more stars, twinkling stars in the background, no stars by the way. Create a scatter plot with Christmas colors, use basic color names, sizes, even larger size of the robots, draw current positions with different markers. Label robot animation, function animation, create animation, interval. Let's do it like 10 iterations. Yeah, something's definitely incorrect. Let's go again. No, nothing. Okay. I will probably ask other model. Let's go back. So visualize the grid animation robots, blah blah blah. O1 mini. Let's ask O1 mini in normal mode. Yep, cancel. Let's do it like that. We will remove all the code, and we'll add O1 mini for day 14 and normal mode. Okay, let's go. Okay, we have some code, animate in it. Tree pattern. Oh. Where's my additional prompt? Checkpoint saved. History. Christmas animation. And I've asked it what the FPS. Okay, yeah, that's it. Okay, I don't see any movement of robots. make. Okay, alright. Now let's go back. And let's firstly see if that's correct. No attribute resize ID. Okay, we'll paste this error. Also fix this one. Why? Okay. I try to generate a diff. I wonder if it's correctly. We'll paste it correctly. Okay, probably. Yeah, frames interval 16 for some reason. Is that it? Okay, let's try. Yeah, nothing has changed. Nothing has changed. Oh no, not agent. Oh, did I? Where did I put it? Yeah, should be correct. What do you think? How would Gemini solve this? The visualization? Gemini? Let's, oh, by the way, it already should have its code, so I'll just prompt it to make the visualization. Yeah, alright. Diff David. Okay. Something is wrong with that. Something is really wrong. Robot movement, and let's ask it to visualize, and and let's try prompting it once again here. Fix also, and also okay, and we have some answer from Gemini, which is animate. Okay, no, no, in a separate file, and import what's needed from just in separate file. Or yeah, because it's in a separate file, we can just copy it. Okay, so again we have something very weird from the O1 mini, and we'll try to accept it. Did it change anything though? Show diff. Okay, there's something here. Visualize. Okay, again, same thing. Okay, let's try with Gemini. All right. Yeah, so we have something from Gemini. And Christmas tree found in time 19,000. No. We had some pattern. I think we had some. No. What? Why? It's always different pattern? No, it's the same. It doesn't look like a Christmas tree though. And the previous solution was correct. Why it's not now? No, like, what's the problem? Yeah, let's say the solution for both parts is correct. Now for the second part, let's visualize. Okay, let's go again. Visualize. Yeah, input. And let's go. Yeah, it's just giving me the same problem. Same issue. Solution. Okay. No, in a separate. No. Here. And should remove. Let's remove this first. Delete and delete. Okay, we have code. Let's go. Rest of code, read in. Now. Let's do that. Visualize. And let's try to run. And what? And what now? Animate robots. Should we just run, like run this function? Animate robots, read input. Okay, function animation, no resize ID. Why? What happening with what's the problem? Close event. Oh, so the issue was not here. Okay. Now it should see that the issue is actually yeah, too many indices for array is one dimensional, but two were indexed. Okay, you're right. Here's correct code. Animate robots. Okay, let's see. Okay. Instead of scatter set of sets, we now use another thing. Okay. Let's go copy the animate robots. Let's close this one. Animate robots. And Yeah, all right. Let's go. Same problem. Why? Okay, now an NP is not defined. We haven't imported numpy. Okay, all right. It's not what I not what I wanted. So firstly, there are too few robots. Secondly, it's just too slow. I don't know. Again, I really like to visualize this one. So again, let's use Gemini code and let's apply Claude Sonnet. Create because Gemini didn't understand what I wanted. That I want 60 FPS and the other stuff. So solution for both parts is correct. Now for the second part, visualize in separate file, which is visualize. Visualize. Why? Okay. Yeah. So okay, accept, and we have visualization file. No module name Gemini 1206. Let's change it a bit. Okay, all right, now it's correct. Yeah, something is wrong because. So firstly, no, like I don't, I see what's the problem. Let's do simulate robots time is Christmas tree return time. Then what? Oh, it's not that. Visualization. Okay, let's see. Subplot figures and axis, figure size 12, 10 and 12, 10 and 12. Probably that's was incorrect because it's like 101 and 100. Okay, with high figure size. I could be incorrect. Yeah, it's definitely a different picture now. And there's no Christmas tree. Okay, so what can we change? So we have interval, which is 100 FPS. 1000. So because we should wait for 6,000 iterations. Christmas tree should be formed. Let's should wait a bit. Okay, so it's more smooth now. No Christmas tree still. What's the problem? Okay, so probably we need to like yeah. Can we what if we remove Okay, it's just 1 second. Okay, 1/60. Still no Christmas tree. I'm definitely not sure what's happening in function. Okay, there's something else. 1000. Okay, time frame. I see now. Could be that there's no, that's frame. So calculate real time. 1 second is 1000 iterations. So what if we do like what was the answer? Is this number? So let's do it again, but we need to see the iteration at the very end and stop. Okay, we have something now. So apologize for error. Let me try again. What are you trying? More focused edit was some error. Okay, let me make one more edit to ensure the animation runs exactly 60 FPS and scales time correctly. Okay, accept all. Probably hasn't finished yet. Yeah, okay, should be okay. Animation is not defined for some reason. What is that? What is that? Visualize. Nothing here. Where did you store it? Okay, so no. Okay, accept this one. Let's see visualization and how long do we need to? Oh yeah, it stopped, but it's not the correct. I don't see any pattern there. So let's apply another change. Apply, okay, accept. And let's apply this one again. Okay, nothing has changed. Nothing has changed. And let's see, so I don't see anything for this iteration. What it looks nice, especially those stars that are blinking. Continue running until exactly iteration 6512. When it reaches this iteration, special message indication. That's the final formation. Let's see. So yeah, we need to wait, or it just takes too long. I need it to run within 6 seconds until this iteration. It's still going on. So yeah, it wants to adjust the scaling. Let's close this one. Let's accept and let's run again. Okay, 1, 2, 3, 4, 5, 6. Should be finished by now. Yeah, there's no Christmas tree. Okay, let's let's do it another otherwise. Let's just show the plot without any animation on the this iteration. Okay. Okay, let's see. Yeah, there's nothing there. So where's the Christmas tree? This was the correct puzzle answer. Fewest number of seconds that must elapse for the robot to display Easter egg. So what's the point? Let's try 6, 5, 12. Iteration. Let's try 13. Yeah, nothing on 13. Maybe it's 11th. Nothing is there. Okay, maybe just not all the robots are shown. Let's go again to 12. Are you sure that we can see all the robots inside? Make sure the logic is correct for their movement. And the plot size is correct. Let's try to search code base for how the robots are moving and what size in grid simulate robots. Robot movement is in simulate robots is visualization is correct dimension with plotting. However, let's make few adjustments to ensure that you see all robots clearly. Let's see again. Yeah. Robot count +1. Oh, it's logarithm. Okay. Why don't we get anything on this grid? Are we using the correct input data? Probably yes. So read input.txt, input.txt. All right. So Claude just has another Claude, but the agent, well, I haven't seen it, just trimmed the input. Okay, there's definitely a Christmas tree, and it's upside down even. Wow. So what should we do now? For our visualization purposes, now that's what we get. Make the visualization again, and animation, the animation again, and what do I want, and improve the coloring scheme. Okay. Okay, we have something now. Let's see. Oh wow. It takes a little more time than I wanted. Okay, let's make it finish faster, and let's increase the FPS by 2 factor of 2. Accept, and let's run it. Let's run it. Okay. And we need to also, yeah, turn it upside down. It's not finishing faster though. Also, like, how this called, mirror, like turn the image, like plot upside down. Okay, let's go. Okay. Yeah, perfect. All right, so we got our answer. We got our visualization. Yeah, and I'll be finishing on this. Thank you for watching, and have a nice day.